The world's only and cheapest counterweight 3D printer. What? In this video, I'm going to show how this super cheap, super simple 3D printer with a wood frame works. I'm going to build another one of these printers soon, and I'm going to have a full list of all the parts I use, as well as a very detailed video, exactly all the steps you need to do to build this. So I take this 3D printer to a lot of maker spaces and stuff. So for teaching, it's great because there's nothing blocking the part. You can really see how the plastic's coming out. Also, you can see all the parts. They're completely open. You can see all the wires. You can see everything, what's attached, where the stepper motors are. And it's such a simple printer that students, even younger students, really feel like they could make it themselves. Like a Bamboo Lab with really complicated sensors and everything. Not a lot of people feel like they could build that kind of printer. But this printer, they see the really good prints that come out of it, and they really feel like they can print it themselves. Like this Einstein head, this is what I was printing at Maker Faire. This came out of this printer, and the details are fantastic. We've been talking about this 3D printer. It's pretty small, so it's mobile. But there's also this one, which is the same design with a counterweight. And this uses 400 millimeter rods instead of this one that just has 200 millimeter rods, much shorter. It's basically the same design, just this is a little bit longer, so that this axis is a little bit stiffer, like just over 200 by 200 by 200, like your standard like Prusa printer. You can see the counterweight's all the way at the bottom, and this is what's happening. See, it's pulling up this belt. That's rotating. There's stepper motors behind there, and it's pulling this double belt up, and then the counterweight is pulling, keeping the tension on the motor and going down at the same time. Just about at its limit, which is about 100 millimeters. The 3D print is half as tall as the counterweight dropped. So you see the counterweight went from there to there, and the 3D print is only this tall. And that's because there's two belts here, so that gives me more resolution. So this belt has to move twice as far as the Z-axis moves. So this printer is really built with all the cheapest components. I have wood structure, then there's a lot of 3D printed components, then simple linear rails, 8mm linear rails, and cheap bearings. I'm securing the bearings here with zip tie and then hot glue to hold its position. Really trying to make the simplest, cheapest printer here. Even the power supply. This is a power supply I found in the garbage. It's 12 volts and 3 amps, which is like almost no power. Because it doesn't have a heated bed, it kind of works. I think it's just on the limit for the hot end and the stepper motors running at the same time. And for cooling, there's no part cooling fan. I just glued this small computer fan to cool the hot end, but there's nothing to cool the parts. Yeah, no heated bed, no limit switches. So these are the more complicated parts. This has like an idler pulley, holds 2 rods and holds 2 bearings. And here's just the stepper motor in the back. Then here there's a stepper motor for the Y-axis. This is a stepper motor for the X-axis. Then we have just a Bowden system. So we have this really cheap from AliExpress. All the parts actually are from AliExpress. Really cheap extruder attachment for a stepper motor. And then I 3D printed this piece that can fold in. So everything folds in so I can fit the 3D printer in a box. Also here, this folds in, has a pivot. I think it's a V6 hot end, the really cheap standard hot end. It has a 3D printed hot end holder. So lots of people ask me about this. The counterweight is a 2D printer motor. So I took apart a normal paper printer, a 2D printer, and this motor was in there, and it has this like PCB board, and there's a space to fit the belt under. It's not so big that it doesn't hit this as it's going up. This is coming down. It doesn't hit that. It has quite a bit of weight, enough weight to keep the belt tight on the stepper motor. And I was thinking of printing like a holder so I could put some metal in it or something, but this just works. And I like that it's a weird counterweight. It's just a motor from something I found in the garbage. So I also use a lot of like 5mm bolts. So here, this is a 5mm bolt with a nut and washers. And I got a lot of these like idler pulleys that have bearings inside for a 5mm diameter. So that works really well. There's a lot of like just wood screws to hold this in place. Then here There's again like M5 5mm bolts holding this together. This idler pulley again has a 5mm bolt with nuts and washers on both sides. So first I get off the part that I 3D printed. There we go. And then I have to wash. To wash glue stick, I just put it under the water. I have to be very careful with this mirror. It's about 2mm thick. Just this IKEA mirror. It's very easy to break. I'm pretty sure if I just like dropped it a little bit, it would shatter. So before I put the mirror on, this is how I leveled the bed. I just cut off these pieces of plastic and some layers of cardboard and paper. And at 3 different points, I leveled the bed. So it's like a triangle to get it level. The back should really be in the middle, but there's a belt there. You can see there's this belt for the y-axis. So I have to offset that one a little bit, but that works really well. So I just print something, I do like a big circle, and I see where it's squishing too much, where it's squishing too little. Then I add some, bed leveling shims. Then I print it again, and I do that until it's printing reliably. And once it's set up, it's pretty much perfect then. There's no reason why it should become unlevel. So I just take this mirror that I've cleaned and dried, and I just carefully put it on the supports for leveling. And I've marked off where I can put these clamps. So I put these 2 clamps here. So I have to make sure that these clamps don't hit the rails and the belts at the bottom. So there's 2 clamps in the front and there's 1 in the back. Then I have to add some just normal glue stick, like kindergarten glue stick, on the bed. So here we're going to spell maker. So I think it's a long print. So it's good to know what the print looks like, so you can just usually put glue stick on where you think it's actually going to print. So I always put extra, so because if it prints on just glass, it won't stick. Then with this super cheap printer, it has no limit switches, so I have to physically push it back to home, and I have this little mark here. Move it down with this wheel, down to there. Then I can select the print. So it's just a Ramps 1.4 board and this screen. These are all like just the cheapest components. So I want to print the maker. Print 137. So nothing happens, it's just heating up. So this is just the hot end. I don't have a heated bed, so it's just heating up the hot end to 210. So it's almost hot here. And when it gets hot, it's gonna try and find the limit switches, but it won't. And then I'm gonna have to force it down. So I use this wheel and I force it down to try and get the right amount of squish. So it should start just about now. Yeah, there it does some stuff. And then I have to I have to just do this here with my hand. Try and lower it. See, it's way too high. Down, down, down. Until it just starts to, that's too much. Now I can see the letters. This printer is also super loud. I've wanted to make it quieter, but it just, when something works for me, then yeah, it's hard for me to kind of fine tune it. Here's one of my early designs of the 3D printer. This is actually a dimension of the belt holder, and then here it's showing all the different axes, and it's showing counterweight. I guess this side was on the left side. Also show the Z stepper motor with a gear ratio here, which is not needed, and there's only 1 belt here, so you actually can replace this 2-to-1 gear by just having 2 belts. I didn't know that yet. This is kind of the next step I want to do. I want to suspend this whole thing by belt, so the whole Z-axis is floating, but then move the X and Y all on the Z and have it all go up and down, and then having a stationary like auger and grind up plastic bottles or something, so have it using recycled plastic instead. Here's a look at the CAD I have in Fusion 360. So for me, the CAD is mostly like moving the axis, seeing how much space I have, and sizing all the components. And of course, the 3D printed components, they come straight out of the CAD model. So you have a CAD assembly model, and then you 3D print each of the 3D printed components. And this is a model of the larger 3D printer that I made. And this is with some nice wood color. This is a much older 3D printer I designed and built, and it has a CNC style Z-axis. There are a lot of problems with this. The 3D printer is much taller, and the X-axis has a lot of extra weight on it with the stepper motors and the rails from the Z-axis. Build video for this printer, link in the description. But don't build it! Counterweight printer is better!